Let's start. So should I turn on my camera? Good, good day, everyone. Welcome to our second class for this program. The class is supposed to be for fundamentals to C# because that's what we're going to be touching on this week as fundamentals to C#. So that's what the class is supposed to be for. We're going to be doing a little bit of C# console applications. That's what the task will be on before we jump into API development next stage, right? So I assume that most of us who are already here must have gotten to stage 2. And I also assume that we either have knowledge of C# fundamentals, or we have or we've gone through the videos that was dropped in the announcement channel. That's my assumption, right? But then I also assume that some of us might have questions as regards what we know already as the fundamentals to C# or some basic C#. What do I call it now? Concepts, right? Some of us might have questions. So I would like to start with what are some of those questions that we have that would like us to discuss before I would also point out some things that I would like us to just look at before we give the task for the week. So in the next 2-3 minutes, if you have any questions, probably raise up your hands and then I'll call you to comment or to ask a question, or you can also put a question in the comment box in the next 2-3 minutes. If you have any questions, raise up your hand to ask or put a question in the comments box. Nobody has risen up their hand. Does that mean that we are all comfortable with C# fundamentals? Because the task is going to be heavy. I promise. The task is going to be heavy. You're going to at least touch on all programming concepts, right? Yeah, I'm just going to touch on all programming concepts from variables to conditionals to loops to classes and objects and the rest of them. We're at least going to touch on all of these programming concepts, right? So any question at all from any of these concepts, then just ask and we would talk about them quickly. No questions. All right, that's fine. That's fine. So I guess we can just touch on some of these concepts. So what I'm going to do is I'm going to share my screen now. And then we'll just quickly touch on some of these programming concepts, like I said. Coming, trying to share my screen. Yep, let's do this. So you let me know when you can see my screen, please. Let me know when you can see my screen. Can we see my screen?
Yes.
Okay. And I need someone else to confirm that you can see my screen.
Yes, I can see it.
Okay. And is my voice very audible?
Yes, it's audible now.
Okay, okay. All right. So give me 3 minutes. Let me check my gen, please. 3 minutes.
Okay, sure.
So the first thing I would like to talk about is I'm using Visual Studio Code for this presentation. I'm not using Visual Studio. So that means that the process for installing .NET on my system is to get the SDK from the website that was shared in our first call, right? I already have the SDK on my system. So I'll just do .NET dash version, I think. Yes, exactly. So I have 7.0.1.102 version on my system. And I think I also have some other versions. And I'm not sure I can remember how to get the I wanted to point out
.NET dash info.
Say that again.
.NET dash info to get the list of your SDKs.
Okay. Okay. Well, this isn't what I'm looking for, but I think I can see 5-year, I can see 3-year, 2, and then 6. Yeah, so this shows the list of the SDKs I have on my system, right? But then if I try to install a program, it would use this version 7, right? So that's what we're going to do. I'm going to close this and install a console application using .NET new console. First off, let me check my directory. I would like to do this in let me see. Okay, let me do this in the desktop. And then I'll create a directory called, let me zoom this in, yeah, so that we can see what I'm doing. Okay, so I'll create a directory called egabe.com, and this is where I am going to create the console application. So I'm going to use .NET new console and -n. I'm going to call this basic console. So -n means what name I'm going to give the console application. I could also use -o, which says what's the output, where would this console application be coming out from, right? So I could use n or on or o for giving it a name, right? So I'm just going to do this, press enter, and I'm going to create the console application. And if I do check the directory, and I'd see my basic console application in there. So I can cd into that application and code dots r. So I'll just open the application in this Visual Studio Code. All right, great. So can we see the application here? Can we see the console application? I hope you didn't stop sharing the Visual Studio. I hope you can still see my screen.
Oh, I can see it.
Awesome. All right, so before I do anything, I'm going to point out the output of this application, which is the program.cs file, and the CS proj is where we have our libraries and other registered properties, right? Then obj files are just generated files that we probably need to run the application. So you do not necessarily need to do anything in the obj files. And there's also supposed to be a bin file, which you also do not necessarily need to do anything there. So that's the bin file as well, right? The program file is like the entry point where you can start writing your applications, and then it takes it off from there. Awesome. So I'm just going to run this to make sure that it's running fine. It's supposed to print out this console.writeLine hello world to the application, to the console. It's supposed to write that to the consoles, taking a minute. And while we're waiting for that, I'm just going to put this down here and just write some few things that we're going to look into. The call isn't supposed to be a long one, but let's just see. Variables, conditionals. Yeah, so we have our hello world printed right here in the console, so we have that working. Then we look into loops. What else? So let's just do classes and objects, right? Yeah. Then yeah. So just quickly look at this, right? So basically variables, very simple, right? So also variables are like buckets, right? You store values in them, right? Or you store things in them. So you have like a bucket, and that bucket, you could use bucket to store water or items in your buildings, right? So to have access to those items that are stored in that bucket, all you need to do is get that bucket, right? So variables are like buckets that we use to store. So I'm going to try to be fast and not so fast, right? And I'm also going to try to use basic things to explain these principles, right? Because I believe that when you use basic things to explain, it's relatable and it's easily absorbable, right? So do not get angry when I just use basic things to explain some of these concepts. That's how I learned them. Great. So we in C#, you have to specify the kind of container. Buckets are not the only containers that you could use to store items, right? You could use like a poly bag or a nylon sachet. You could use a bucket. You could use your wallet. You could use your building that you're staying in can also be like a container that stores items in it, right? So the same way, it works the same way for variables in C#, right? We have like different types of containers called data types that you can use to get or store values. And I'm going to list just 3 or 4, right? One of them is called strings, and this is just to store alphabets, A, B, C, D, E, F, G, H, I, J, K, right? And alphabets to put together, right? Another is called character, which is used to store character, and then like char is the name of the data type. It's used to store like a single character, right? Then you have like bool, short for boolean, and used to store true or false, right? Those are the only 2 values that you can store in booleans, true or false. Then you have ints, and we used to store numbers from 0, 1, 2, 3, 100, 200, right? And then, so there's like a limit for C#, there's a limit for what int can save. So then you have something like long, which is like int, but then you're able to store in it more values than integers can store. So you have like a 25 liters bucket, and then you have like a 50 liters bucket, right? So it's more or less saying like, okay, integers are 25 liters bucket, and then longs are like 50 liters bucket. That gives you access to more space, right? So you might want to look that up on the documentation in the Microsoft documentation. Then you have like decimals that you could use to store decimal places. Then you have like I said 3 or 4, and I've gotten to like 5 or 6. Let me just pull one more. Let's see. Can't remember one more. Anyway, so now how can we retrieve these these variables. All you need to do is just call the name, because the way variables are stored, I'm going to do this, is data type, name, then value. That's how variables are stored. Data type is like, what kind of container is it, right? What kind of container is it? Name is like, what's the name given to that container? So if I want to go and get that container, first off, I'm like, okay, I want to go get buckets, right? Then what's the color of the bucket, or what's the shape of the bucket, right? What's the name on the bucket, right? So that's the name. Then what's inside the bucket is the value, right? So we have the data type, what kind of bucket is it? A string. What's the name on the bucket? A. What's the value inside the bucket? Hello. Same thing here. So now, if I want to use this, all I need to do is just get the name, console or write line, get the name, and I just want to print this, right? And we're good to go, right? I could just do that and then I'm using it. And if I want to use it like multiple times, I would just call that name of that bucket. Now, another advantage is that if I want to change the value, imagine I have like hello, hello, hello in 500 places, but then I want to change that hello from hello to hello world. If I just change it in the bucket, then it affects that 500 places. But if I don't have it, I have it in 500 places. I have to change hello to hello world in 500 places. That's another advantage of using a variable to store your value. Okay. Do you have any questions from variables? Should I proceed to the next?
Hello.
Yeah.
Okay. I just want to ask, for example, that variable you created string that has a string A.
Yeah.
If we want to reassign that variable without changing it from the bucket, how do we do that?
Yeah, you can do that. You can reassign a variable to have like a different value, right? But in this case, you don't need to now you don't need to say string A again. All you need to do is just do A equals world, right? So if I do this and run this, what we should see is hello world and world, right? So I'm printing A here and I'm printing A here as well, right? So as you can see, hello world, which is this first hello world, which we don't need anymore, then hello world and then world. So I've successfully removed. So after using A in this line 12, I've successfully removed what's in it and replaced it with something else and then used it again. So it's more like, oh, I got the bucket, I used what's inside the buckets, right? And then I want to give it to you. Instead of me giving it to you with what's inside the bucket, I put something else in the bucket. What you're going to be having is that stuff that I put in the bucket, right? Even though I had access to what was in the bucket in the first instance, once I'm giving it to you with something else, what you're going to be having access to is the new stuff that was put inside the bucket. I don't know if that makes sense.
Yes, thank you.
All right, great. Any other question? All right, great. Now, moving on to conditionals, right? Conditionals is like, so like it says conditions, right? You have conditions and you have to make a decision, right? I'm going to give you an example. You're working on a part and you have two roads. There's no way you can go on those two roads. You could either go on one road, come back and go on the second road, but at a singular time, you can't go on those two roads. Now, there should be a condition that now helps you decide on which road you should go to, and that's conditionals in programming, right? So now you're like, okay, I want to get to the stream. Does this road lead to the stream? Yes, I follow that road. Does this road lead to the stream? No, I'm not following that road, right? So that's conditions for you. Are you hungry? Yes, go and eat. Are you hungry? No, do not go and eat, right? So that's conditionals in programming, and it's very easy to implement, right? So it's just like English. If I am hungry, then eat. Else, don't eat. Right? If hungry, eat. Else, don't eat. This is now to write it actually, right? So I'm just trying to make it readable, so that you understand what's happening. And this is conditionals for you. Now, what is going to be inside here, instead of just saying if hungry, is supposed to be like a condition, right? That is supposed to be either true or false. And now that condition allows you to enter this block, if the condition is true. But if the condition is false, it allows you to go into this other block. And that's just what it is. Now, how do we write conditions that are true or false? I'm going to start with a simple condition. If 7 is greater than 8, okay, I'm just going to comment all of this out. And do this. At this point in time, let me see what this is saying. Unreachable code. Okay, yeah. So it's even telling me before I run the code that it's not going to pick this, right? It's telling me that it's going to pick this. And that is because 7 is not greater than 8. So this is going to translate to be false, right? So if 7 is greater than 8, which is false, everything inside of here will be ignored. And then everything inside this else part would be accepted. So this is like the two roads. You have one road and we have another road. And I'm going to decide which road to go to on the condition put inside this block. And I'm just going to run this now. And I'm sorry, I do not have a paid Zoom software. So the meeting is going to be capped at 45 minutes, right? And the first 45 minutes is almost over. So in 9 minutes, the first 45 minutes will be over. So if the call ends, all you need to do is join again with the same link, and then you join me back on the call. So just don't worry about that. All right, great. You see that what was printed is no, right? And that is because 7 is not greater than 8. Now, if I switch this around, if 8 is greater than 7, then it's going to be translated to be true. And you see that it has changed, right? It already knows that it's never going to get to this place because 8 is not greater than 7, as you can see, right? So that's how conditionals work. Conditionals work on a decision, right? And the decision is whether something is true or false. Now, another conditional would be, let me see, is 9 equals 9. Now, this, what I'm doing right here, even though it's in the conditional field, I'm trying to remember what it's called. It's not arithmetic equation. It's something else. I'm trying to remember what it's called, but let's just flow with me. Now, if 9 is equals to 9, and you are seeing that my equal sign is double equal sign. So I didn't do if 9 is equals to 9. This is wrong. And why is this wrong? Can someone explain why this is wrong? Why it's not just one equal sign, but two equal sign? Can someone just help us with that?
I think that is because one equal sign is an assignment operator. Then 2 will be for comparison.
Exactly, exactly. So that's the difference, right? So I'm going to just write that here. Equal is an assignment operator. Is for comparison. Now, what it means by assignment operator is, as you can see, we're using one equal sign here, right? So what is happening here is we're assigning this value to this data type and variable. We're assigning this value to this data type and variable. So that is what one equal sign is for. It's for assigning a value to a variable, right? But two equal signs is used for comparing two values, right? So it doesn't mean that you have to do two equal sign or two greater than sign when you're doing comparison between two values. No, for greater than or lesser than, you can just do this, except when you're also doing greater than or equal to or lesser than or equal to. And this is how it works. Is it greater than or equal to, you put your greater than sign and then your equal to sign in front of it. Is it lesser than or equal to, you do this. And that is how that works. Now, how do you check if it is not equal? All you need to do is use your exclamation mark. I'm going to use, let me see, use your exclamation mark to check if it's not equal, just like that, right? So this is saying, is 9 not equal not? This is the not expression. Let me just put that up here. Is the not expression, right? So not equal, right? So it's not, this is not equal and equal. It's not like greater than and equal. No, it's not equal. And it's, as you can see, 9 is equal to 9. So it's already saying that it won't get to this code, but it will get to this code. And that is what conditionals are, right? Now, what if we're trying to do like, we're trying to check two things. We'll need to make sure that two things are equal, or we need to check that two things, or we need to check that one out of two conditions are true, right? So, you know, when you're making decisions in real life, sometimes your decision or conditions do not have to be straightforward, whereby you're having like, do I have money? Yes, buy this. Sometimes it's, do I have money? Yes. Do I need this money for something tomorrow? Yes, then I'm not buying, right? Do I need this money for something tomorrow? No, I'm buying. That is two conditions, right? Now, some conditions are all conditions, right? So when you say we have like checking two or more conditions, we have and conditions and we have all conditions. Now, and conditions mean that those two conditions will have to be true. The first and the second. Do I have money? Yes. Do I need this money? Yes. They have to be true for me to decide. Do I have money? Yes. Do I need this money? No. Then I go this other way. Do I need this money? Yes. And I go this other way. They both have to be true. And how do you do that? You have to say, you have to use the and symbol that is you're already familiar with. And you're saying like 7 lesser than 8. As you can see, first, this is false, so it's not even going to matter. The second condition is not going to matter because and operator needs both of them to be true. So it's more like saying, so this condition is like saying false and 7 is lesser than 8 true. Now, so this condition is false and true. Because it's an and operator, this is going to translate to false. Now, what's true and true going to translate to? Somebody?
True.
True, exactly. True and false going to translate to what?
False.
False, exactly. Then finally, false and false is going to translate to false. There's no way about it. False and false is going to translate to false. The same thing. Now that's for AND operator, right? So let me also just extend this a bit. True and true and true is going to translate to true. But then true and false is going to translate to false because AND conditions needs everything in that line to be true before it would go into the block. And this is the block. The same thing for if it's false, it's going to translate. If any one of them is false, it's going to translate the whole thing to false and then go to the else block. Now, okay, it's just 1 minute 33 seconds to go. So I'm going to just stop here, restart the call, and everybody should just join immediately, please. Thank you.
Okay.